Hello and welcome back to the Code Athlete. We're now in the year 2022 and the new season of Kickstart and CodeJam have just started this weekend. And the Kickstart round was in German time in the night, so I didn't participate. Maybe if you watched my previous videos, I also promised you to participate in Kickstart round H last year, which I haven't uploaded. I recorded it actually, but it was also in the middle of the night in Germany here. And I got actually a pretty decent rank, I think close to top 100. But my commentation on the problem solving was really bad because I was super tired actually. And so I decided not to upload my solutions there. Yes, but now I decided not to do the night rounds anymore. I will just use the round A of Kickstart as practice, and I will upload each problem separated, as I did previously with round F, I think, Kickstart round F last year, to refresh my coding skills and be able to successfully participate in Google CodeJam. So Google CodeJam will always have my main focus, and I basically use Google Kickstart just to keep practicing. Yeah, so in this video I want to have a look at the speed typing problem. The name suggests that it's maybe a super simple problem. You just need to super fast type the solution code. There are even people here who have solved in under 2 minutes, here under 3 minutes. Well, I'll try to explain a bit of my thoughts, but it's probably going to be quite a straightforward problem. What do we have? Okay, Barbara is a speed typer. In order to check her typing speed, she performs a speed test. She's given a string I that she is supposed to type. While Barbara is typing, she may make some mistakes, such as pressing the wrong key, which happens. As her typing speed is important to her, she does not want to spend additional time correcting the mistakes, so she continues to type with the errors until she finishes the speed test. After she finishes the speed test, she produces a P. What is a P? Now she wonders how many extra letters she needs to delete in order to get I from P. So P is a completed string from her with the mistakes. It is possible that Barbara made a mistake and P cannot be converted back to I just by deleting some letters. In particular, it is possible that Barbara missed some letters. Help Barbara find out how many extra letters she needs to remove in order to obtain I, or if I cannot be obtained from P by removing letters, then output impossible. So we're just looking for extra typed letters. This is, I think, very simple. Okay, just case has 2 lines. Yeah, I the target and P the produced string. And impossible if it's wrong. The length of the strings are not too long. We can just linearly iterate over them. That's fast enough. Target word, produce word, we can just delete one A. So the answer is 1. Target word has 5 B's, but the produce has only 4. So just by deletion, we will never get 5 B's. So this is impossible. Fair enough. All letters in I are the same in tested 1, not in tested 2 anymore. I love coding. And she doubled the I and the L, so those are 2 that needs to remove. Kickstart is fun, that's true. But she typed 2 small K's instead of 1 big one, and also here small I, small f. So she can never recover this one. What are the letters actually? Okay, all upper and lower case letters. So how could we approach this? I'm suspecting here that all the same letters case is some indicator how we could actually solve this more complicated test case. Yeah, I guess we can just start from the beginning of the I string and the P string. Start from the beginning, reading in the letters. And for example, we start with the I string reading in the first letter. In this example with I love coding, this would be an I. And then we start with the P and we get also an I. So we shift, we found a match, we shift both strings by one. So this is now at the L. And here we get another I. This is not matching, so we increase our counter by 1. We have a mistake counter basically. So counter is now at 1. And we shift again and we get small l, which matches, so we shift both. We get here the O from I love. Here we get another L, which doesn't match, so we shift the P, have a counter increased, get an O. Matches, we shift both. And now everything matches. And when we get here the end string, we just need to count the end token basically. We just need to count how many letters here are in the end till we have also emptied P. And then we count the mistakes. And in the case we never reach end here, but here first, it means we couldn't have matched them. This is basically a greedy approach, and it should always work. Yes. Because of course they have to be in the right order, that's why we can just reverse them. Okay, let me just copy over the samples. Directly aggregate them. Yes. So we need a default val trigger. The result type is an integer, and if we set this to -1, then we want to trigger the default value, which is impossible. That's our template here. Get the two strings I and P. We set result, which is the counter for the mistakes, to 0. And we have two pointers, E pointer and P pointer. Start both with them at 0. While E pointer smaller than equal size, means we still have a valid letter in I to match. The case where this letter matches the current produced letter, we just increase both pointers. In the else case, we just increase the produced pointer string. We increase the mistakes by 1. And now we might be at the end of the produced string. So if we are at the end, we want to actually break, and we want to set the result to -1 because It means that the case is impossible. Z, by the way, is a shorthand for the string size. Yeah. Need to bring a problem folder A. We produced a value of 0 for our first test case and not 1. The other ones seem to have worked. We need to, of course, when we finish this whole string, we still need to add all the additional letters to our result. This is basically p.size minus p pointer, right? Yes. This is in the case where result is not minus 1. Let's do it like this. Okay. You can submit this, and this should give a valid solution. So again, just have these two cases. Either the pointer position matches, we just need to increase our pointer positions in the string, or it doesn't match, then we have found a letter that we need to remove. So we just skip it by increasing the produced pointer, adding a mistake to our result counter, and we check if we already traversed the produced string. And the check that we traversed the input string is basically here in the while loop. And then we just need to make sure that if we finish the input string, we need to catch any additional letters that were produced actually, and also count them as mistakes or as letters that need to be removed. So you can already see that we passed the test. And yeah, I will continue to do these short videos, going through the problems here, B, C, and D as well for Google Kickstarter Round A. And of course, if you like this video, leave a like or a comment. If you have any questions, I'm happy to discuss them. This is how I practice for Google CodeJam. I got a few questions on my past videos, how I'm actually practicing for these contests, and the most important thing is just to go at the problems. Very important, take on problems that you can actually solve, where you have a chance. If the problems are too hard, you can usually see this if you take longer than maybe half an hour or an hour for a problem. Maybe put it by side, look for something easier, and come back to it later, or look at solutions. You can see here, for example, Google Kickstart and also Google CodeJam. They have also always an analysis page on the problems. They show different kind of solutions and why they're slower or faster. So again, I think, I haven't read this, of course, but usually it's like they have one solution which is very simple and only runs on test set 1, and then they have a more elaborate solution which runs on the bigger test sets, and they explain the time and space complexity of their programs. So this is also an important aspect, that you can manage to quickly estimate if your program, your ideas will be fast enough to solve a certain type of problem. I've mentioned this in previous videos, but the rule of thumb for me in C++ is you can do about 1 billion operations in 1 second. So 10 to the power of 9. And I just estimated here, yeah, my algorithm just linearly goes through all the letters in the string. And if the strings are to the 10 to the power of 5, it's basically 10 to the power of 5 operations. and that's below 1 second because, like I said, 10 to the power of 9 operations is estimated to be 1 second in C++. So yeah, that's how I knew it would be fast enough for this input size. This again can give you also hints if you have like more complex problems. You can look at the problem size of all the parameters you have. Usually there are more than just 2 parameters for complex problems. And you can look at your time limit, and you have usually 100 test cases, and you can estimate. It doesn't need to be a logarithmic solution in the parameters, or a quadratic or cubic solution. And the nature of this complexity estimate, quadratic, cubic, or logarithmic, can guide you in finding actually the algorithm to solve the problem. So if you have the feeling you need a logarithmic solution just by the problem statement, you can actually think more about binary search, or binary search is really the most common logarithmic algorithm. I mean, there are many variants of algorithms which basically come down to this splitting in two and dealing basically the divide and conquer approach. Those are usually like recursive algorithms which yield some kind of logarithmic time complexity. And if it's quadratic or cubic, it usually means you need to test some kind of list of combinations. So if it's quadratic, maybe all the pairs from 1 to n, where n is this parameter, or cubic even triples maybe, that you just have to iterate, and it might be fast enough. So just some insight on what you can practice and what is important for these type of problems. Of course, speedy programming itself is also quite important, but I think people usually struggle more with actually solving the problems on the theoretical side. Coming up with a solution that's fast enough for the harder rounds. And then of course there are some problems which the top players in competitive programming, they all basically solve them. Then again, it's about the speed of implementing stuff. But you first have to get there by solving actually the problems, and that's just needing a lot of practice, intuition, and reading actually through the analysis of some solutions. That can really help. I really encourage you to do this, even if you solve a problem, just to see the other approaches or if there is one more efficient one. Or have, of course, a look at some of my videos, of my older ones or my future ones. So keep up to date. I will definitely do an online streamed version of my complete run through Google CodeJam qualification. It's usually 4 or 5 problems, I think 5, and I hope I might make it in under 3 hours. That's my goal, at least for this year. So yeah, have a lot of fun. See you, and ring the bell if you don't want to miss my qualification. Have a good one. Bye.